Okay, I'd like to demonstrate a guillotine jig today that's been modified so that you can control both forces during the flute rather than just one. What I want to show you first is just the standard guillotine jig and how that works, and then we'll get into this apparatus over here on the right, which is the modifications I made to it to allow better control of the fluting process. So first we'll show you just the standard guillotine jig, and this is it. This particular part of the jig was given to me by a napper in Texas. I don't remember the guy's name, but we did some trading, and he was quite skilled with carpentry, and he had a number of these in his truck that he was trading to various people, and it's well built, and I decided to give it a try. I was using a Solberger jig prior to that. Solberger jig gave really good results, but it's a little bit awkward, at least for me, to use, and I wanted something that might give me a little bit better results and was easier to use. So I thought I'd give this thing a try. And basically the way this works is it has a number of holes drilled right in here, so you can adjust the height of your levering bar right here according to the size point that you want to flute. Right now this is a fairly large point, maybe, I don't know, 7 inches long, something like that. This is some Arizona dacite material. I'm just setting it in there for demonstrating, and it's held in place with rubber bands, the Preform, and the tool goes in here like this. We'll show it over here. Makes contact with the nipple right there, and in normal operation you would lift up on this. It's pushing against that pin in there, and that causes the bit to go down, and you would remove a flute. The problem with this is it works, but you really can't control the amount of outward pull. In other words, when you're applying force like this here to get the flute to release, that pressure is going down into it, but you really can't control the outward, which is what starts the crack. So I modified it, and we'll show you that here in a minute. That's what this particular apparatus is right here. Okay, this is the compound lever installed on the jig, and this replaces this particular simple lever right here. The beauty of this is you can control the downward movement of your bit with this lever and kind of optimize just the amount of force that you think you need in order to release the flake or to have it travel as far as you want. This component of the jig right here allows you to put outward force like that in order to start the nipple or the flute to actually release. So that gets the crack going, this particular movement here. So typically what's done, you push down until you preload the Preform with just the amount that you think you need, depending on the size of the Preform, whether it's a Clovis or a Folsom or a short flute or a long flute or whatever you want. When you want to release it, you just hold that pressure steady and you apply some outward force like that, and the flute will typically pop off in this direction. So of course this particular bit right here goes right on here, and I'm going to set that up for you here in a minute. I'm using paint sticks and other devices to sort of shim it, to pull it away from these rails. These rails were intended for the simple levering component, so I've got to modify it a little bit, and I've got some holding devices for shorter points, so we'll demonstrate all of that here in a minute. Okay, this is the Preform all set up in the jig, and I'll do a little walk around here, kind of explain what's going on here with all these rubber bands and everything. The Preform is secured to the jig with rubber bands, as you can see, and it's important that it be secured so that there's no wiggle at all. Typically I'll use even more rubber bands than that, but this is just to demonstrate. These are paint sticks just to bring it out away from the face so that the bit fits in line with the Preform nipple. These little pieces of leather right here, these are to support this in this area, the shoulders of the Preform. That's very critical. If you don't do that, because there's a natural curvature in the point, a lot of times what will happen is this here can move back, and so as you start applying your outward force with this lever, you'll be bending this preform, and it'll typically break or snap right here. So if you have it secured here and here, all of your forces, all of your bending stresses is occurring from here to here. You don't get much of a bending stress or a levering kind of a bending stress as you would if you don't have it supported here and here. You'll be bending the point right at about this point, and often it'll snap. The file down here is just to support the tip. I've got a little piece of leather under it. I can use paint sticks also to shim the preform up or down so that it fits the bit. And of course, the lever itself, the compound lever, can be adjusted here by placing it in holes either higher or lower to fit the length of the preform. In a minute I'll show you a preform, and we'll kind of go over the characteristics that make a good preform and a good nipple, and we'll actually try this thing out on a Clovis, and then after we'll do a shorter point. Some of these smaller ones here, these little blocks work better for smaller points. You don't have to put all these paint sticks in here, and it's just a better holding device, and we'll show how that works. I'm sure there's better ways of going about it. This is just what I came up with. So we'll show you this here in just a minute. Okay, here's the preform. A little closer view of it. And this is Arizona dacite. And this material is kind of similar to Oregon dacite. Works about the same. It's got a lot more inclusions in it, these little crystal pockets. This is what it started off looking like. It's just a river cobble, and there's quite a bit of this stuff out there. And the most critical thing on a preform like this is the contours, the convexity from edge to edge, and of course the nipple and how well it's isolated. So we'll go into all that. Here's the preform. Fairly thin for a Clovis preform. I kind of like that. It's a lot of the real ones were thin, some weren't. This one's kind of wide, and so it should make a nice wide flute. I like to get a flute that goes about half, maybe third. I'm not trying to shoot for the tip or anything like that. When you look at the point, you look at the convexity from side to side, and the main part is in this area from here to here. We're actually fluting. You want to have it fairly smooth. You don't want to have any high spots over here, over here. On the nipple itself, you definitely want this area right here and right here to be low, so that this can release off the edge without putting a lot of undue strain and pressure on there to get it to release. Let's see if we can show you that a little bit better. The other important thing is the back side of the nipple. All of this is explained in Woody Blackwell's video, and it's very excellent on how to do this and how to get it all set up. We'll do the back side after we do the front side here. We'll put it in the device here in a minute, and we'll give it a try. One little noteworthy thing here is when you're isolating this particular nipple, you put your pressure flaker on there, and you don't push straight in. You push out in this direction and out in this direction. And I usually do that in two sets. Do one set, peel it back, and then do another set. You push out because the flakes are actually will fan out like this. And if you push straight in, what will happen is those flakes will come over here, and they'll angle in like that, and they'll create a high spot here. And then what happens is that makes a really weak nipple. Sometimes it'll just pop right off of there. This material being dacite, I had to grind that quite a bit more than I would if it was Texas chert or something like that. You kind of got to adjust your grinding and your nipple strength according to the materials that you're using. So we'll set this up and see what we can do. Okay, I've got it all set up in the this contraption here, and I'm going to go over there and flute it in a minute. I'm just going to kind of zoom in on it. The nipple is in direct alignment with the copper bit there, and the copper bit is filed so that it's a little bit rounded on